Okay, so for part C, we're looking to find um, f of x by antidifferentiating x squared times ln of x. And if you recall with integration by parts, we have the acronym LIPIT, where L stands for logarithmic, I stands for inverse trig, P stands for polynomial, E stands for exponential, and T stands for trigonometric. And we use this acronym as kind of a stepping stone or a pecking order to find what to use for u. And what that means is that if we have an integral that can be written in the form integral of u dv, then that will equal u times v minus integral of v times du. So we use LIPIT to help us assign what should be u. And in this case, u should be natural log of x, and dv should be x squared dx. And so what we're going to do with the natural log is we're going to find its derivatives. And what we're going to do with x squared dx is find its successive integrals. So the derivative of the natural log of x is 1 over x. And the integral of x squared is 1/3 x cubed. Now at the beginning I said that it looked like, or in the previous video, I said that it looked like we were going to have to use the multi-step integration by parts because we had x squared. However, because we have ln x in this, ln x is actually our u, so we're going to find derivatives of that, and we're going to find integrals of x squared. So x squared is not going to wind down as it normally would if it were our u. In this case, it's not. So if u is equal to ln of x, then finding its differential would be du, which is 1 over x dx. And if dv were x squared dx, then its integral would be v, and that would be 1/3 x cubed. And at this point, we're ready to just substitute into, or to use our formula uv, which is ln of x times 1/3 x cubed, or x cubed ln of x over 3, and that's minus the integral of v du, which is x cubed over 3x dx. Now we can simplify the integrand, and we would get x cubed ln x over 3 minus 1/3 x squared dx, which is now trivial to integrate. That's x cubed over 3 plus c. And since I already have a 1/3 there, the x cubed over 3 is going to make that 1/9, or minus 1/9 x cubed plus c. And that's my answer for part C. And I didn't wind up using the iterated integration by parts. And understand why. It's because we would do that if x squared was our choice for u in this problem. But because ln of x is our choice for u, we're going to differentiate ln of x, and instead we're going to integrate x squared. And because of that, the exponent will not wind down. It will just keep getting larger and larger as we integrated that. And so we're done with this problem.